Hello everyone, this is me. Hope you are doing fine. So I'm making this video on radius of investigation of a well test, and I'll be showing how this radius of investigation, what are the parameters that are affected by it. Okay, so let's go into the uh, you know, pen and paper and see how it works. So uh, when you are dealing with the radius of investigation, then it affects few parameters. It affects your, sorry for low quality of my camera. So it affects permeability, it affects time of the test, it affects the porosity, it affects viscosity, it affects total compressibility, which includes the compressibility of both rock and fluid. And then we have some terms that tell about it. So if you are having radius of investigation, which is like if you have different wells, for example, if I am having few wells, for example, my this copy is one well and that kindle over there is another well, and this is my active well through which I am injecting the fluid, and that well is the observation well from which I am taking the fluid out, and I am studying how much effect of this injection is there uh, on that observation well. So like I am trying to test the interference between both of these wells. So so then for example I have another well out there. So you see these two are closer to each other. So if I take the radius of investigation of these two, that would be from the middle of this well to the middle of this well. So that would be for example, if I use British system of units, it will be about I suppose half a foot. It is half foot, and from here to that well, for example, that paper over there is another well. So if I try to measure the radius of investigation, it would be like 1 foot. So you can see the radius of investigation from here to there is a half foot, and here to there is 1 foot. So it's double. So then what does it mean? Which well is better if I try to if I want to test the interference, which one would give better results? So if you have higher radius of investigation, then what would happen with that, uh, a very slight, not that much effect, but permeability might be high when the radius of investigation is high, and might be low and the radius of investigation is low. I know it's quite absurd, but when they are when they are far away, so there is more chance that some kind of horizontal permeability may be existing. So the fluid can flow from inside or from the top or somewhere, from the combination of vertical and horizontal permeability. But in this case there is very low chance that some kind of horizontal permeability is existing, because more space, more chance of more probability existing. And there's another factor, which is time. So I'm sorry, now let's check this below. Suppose this below is another well, observation well. This is the observation well. So it is that now it's about time. So for example, this is an injection well and there is the observation well. The distance is higher as compared to this one. So the time taken for the fluid to reach from here to there would be higher than the time for the fluid to reach from here to there. So the farther the wells are, the more time it takes for the fluid to reach from one place to the other place. And then we have the factors which reduce from this distancing. For example, if you have porosity, so and it seems a bit absurd, but according to radius of investigation formula, if you are having more space, then you are supposed to have less porosity, and if you are having less space, you are supposed to have more porosity. Now again, this effect is very low, like very minimal, but if we try to make sense of it, it doesn't make so much sense. But maybe there is some reasoning behind it. Maybe uh, the flow chain, the spaces between these places are affect are effectively useful, because we are talking about the porosity which is effective, which can make the fluid flow. So the pore spaces which can help us to flow would be better out here than comparatively there, because the fluid might travel like this or like that, or it can go up due to vertical permeability. But when there is like a smaller distance, fluid can have the right porosity, effective porosity, and when there is huge distance, the porosity may be bad for us. And then we have viscosity. So again, higher the distance, the lower the viscosity. Now I know it seems a bit absurd, but let's try to make some sense out of it. It seems like when you have when the fluid travels more, if it's thixotropic, if the fluid thickens as it travels, then this scenario would be bad, right? While at the same case, if fluid thins as it travels, which the most drilling fluids and the injection fluids are, like for example honey, if I keep it at one place it would thicken, while if I make it flow it would thin. Same with toothpaste, if it is staying in one place it becomes thick, while if it is traveling from one place to another, like we are pushing it, then it becomes thin. So maybe the effective light is like that: when it travels more, the viscosity is lower, and when it travels less, the viscosity is higher. So travel more, less viscosity; travel less, more viscosity. Again, the last factor we have is the fluid and rock compressibility, which is again inversely associated with the radius of investigation. So if, for example, this active well is far from that observation well, then the compressibility would be higher. Now why would it be higher? Because fluid is pushing more rocks, more fluids in the way, while if these are closer together, then it is supposed to have less compressibility. Again, why it's supposed to have less compressibility? Because it is pushing the less rocks its way. So again, this way, if we try to just combine all these factors together, so we saw that the effect is very low in mathematics. If you want to say that the effect of something is very low, you have to write uh, a root of a square root of that thing. The square root means the effect is very low, and then there is a constant used in this formula, which again reduces the effect even more. So it is 1 upon 948, which is very close to 9.5 or 1000, which means that the effect is even lower. So what is the effect? Again, permeability may be higher due to higher distance, time, more time it takes to travel from here to there, more time it takes to travel, less time it would take to cover smaller distance as compared to greater distance. So again, more time would be take if the distance is higher. And then finally we have um, porosity. Porosity might be high when you are having less distance, and it might go bad. Again, if you are having higher distance, the absolute porosity, which is the total porosity, would be high. Absolutely, that would be greater. But here we are talking about the relative effective porosity, and that would be higher in this case as compared to that case. So it comes again at denominator. Then we have viscosity. So if the fluid is thinning in nature as it travels, then it would come in the denominator. And finally we have compressibility, which is again the denominator, because it travels more, so it compresses more. So this is the reasoning that I got from this formula. I might share its derivation as well, but I think this is quite important to understand it.